Hi, welcome to my channel. Today's question is a math question in the pre-calculus class. An explosion is recorded by two forest rangers. One at a primary station and the other at an outpost 6 kilometers away. The ranger at the primary station hears the explosion 6 seconds before the ranger at the outpost. Assuming sound travels at 0.35 km per second, write an equation in standard form that gives all the possible locations of the explosion. Use a coordinate system with the two ranger stations on the x-axis and the midpoint between the stations at the origin. This question reminds me of the story of Malaysia Airline 370. Malaysia Airlines Flight 370 disappeared from radar on the 8th of March 2014. Where did the plane crash? Authorities now believe someone on board the Boeing 777 shut down part of the aircraft's messaging system about the same time the plane with 239 people on board disappeared from civilian radar. But an Inmarsat satellite was able to automatically connect with a portion of the messaging system that remained in operation. Similar to a phone call that just rings because no one is on the other end to pick it up and provide information. No location information was exchanged. But the satellite continued to identify the plane once an hour for 4 to 5 hours after it disappeared from radar screens. Based on the hourly connections with the plane, described by a U.S. official as a handshake, the satellite knows at what angle to tilt its antenna to be ready to receive a message from the plane should one be sent. Using that antenna angle, along with radar data, investigators have been able to draw two vast arcs, or corridors. The plane is believed to be somewhere along those yellow arcs shown here. To find the exact location of the plane, other information such as distances from another 2 points of location are needed. Let's go back to our original question. Where did the blast occur? The given information is first, the distance from point F1 primary station to point F2 outpost station equals 6 kilometers. And second, the distance from point P explosion location to point F2 is further than the distance from point P to point F1. By how many kilometers? We know the result by multiplying speed and traveling time. 6 seconds times 0.35 kilometers per second equals 2.1 kilometers. Let's recall some definitions of conic sections. The definition of a hyperbola is the set of all points in a plane, the difference of whose distances from two fixed points, called the foci, remains constant. Now the distance from F1 to origin O will be named C. C equals 3 kilometers. Next step, calculate A, the distance from vertex V1 to origin O by the given information. The distance from point V1 to point F2 is 2.1 kilometers greater than the distance from point V1 to point F1. Thus we can write a such equation based on the difference of V1's two distances from two foci equals 2.1 kilometers. After solving this equation, we got A equals 1.05 kilometers. Next step, find B. Using C square equals A square plus B square. We got B equals 2.81 kilometers. Now we can write down the curve equation. A hyperbola consists of two separate branches that are symmetric. In our particular case, however, only the branch on the left fits the scenario. Since if the explosion happens at the points on the right curve, the people at the outpost station would have heard the blast earlier. So our final graph of the answer is the pink curve on the left side. There you have it. If you like the video, please subscribe or hit the like button if you do. Thank you for watching. See you next one.